Hi guys, I'll be showing you how to read a GIA certificate today. Okay, so this is how a GIA certificate looks like, and I'll be using this as an example. So the first thing you see on the top left is a date, which shows August 1st, 2015. This is the date this diamond was certified in the GIA lab. It is not the date when this diamond was mined or cut, but when this report was printed. Generally, some might prefer a more recent date, but it's perfectly normal or common for it to be 1 to 2 years old. Next is the GIA Report Number. This is a very important serial number which is also printed on the top of the certificate. Each diamond will have its own unique serial number which will never be repeated on any other stone. With this serial number, you can download the soft copy of the report on GIA's website at the link below. This is how you can check and authenticate this report. Now the diamond itself will have this same serial number inscribed on its girdle, which would look like this. Before you buy a diamond and when you collect your ring, it is absolutely necessary to check this inscription number to match the certificate to ensure that this is the correct diamond you are buying or collecting. This is a common trade practice and there is no reason not to show this. Next is the shape and cutting style, which in this case is a round brilliant. If the diamond is cut in a different shape, such as a cushion, pear or heart, it will be reflected here. Then we have the diamond's measurements, which is 6.44 to 6.48 mm by 3.97 mm. The 6.44 to 6.48 mm is the shortest and longest diameter of the diamond. Generally, you want them to be close to each other, as if it's too far, your round diamond will end up looking more like an oval shape. The 3.97 mm is the depth measurement, which is how long your diamond is. At the middle section is what we call the 4c's. First is the carat, which is the weight of the diamond. Many people associate this with the size of the diamond, but what most don't realize is that if a diamond is cut too long or too deep, a larger carat weight diamond can still end up looking smaller from the top view. Next we have the color grade, which grades how yellowish the diamond looks. On the right side, GIA shows the color grade scale, which starts from D, E, F and all the way down to Z. Basically, the lower the color, the more yellowish the diamond is. Also, GIA groups the colors into different bands, such as DEF in the colorless band and GHIJ in the near colorless band. Next is the clarity grade, which refers to the inclusions or blemishes that is in the diamond. On the right side is the clarity scale, which starts from flawless or internally flawless, followed by VVS1, VVS2 and so on. Basically, the lower the clarity grade, the more severe or number of inclusions the diamond has. Next is the cut, which is the most important C of a diamond. The better the cut, the more brilliant, fiery and scintillating the diamond will be. On the right is the cut scale, where the best is excellent, followed by very good, good and so on. However, I have to emphasize that even though the excellent grade is the highest grade on the scale, it is still a very loose term, meaning there is a good excellent and a bad excellent. This is where all these terms such as super ideal cut, ideal cut or normal triple excellent comes about. Next up, we have the polish and symmetry, which are both excellent. Polish is the surface shine of the diamond or the smoothness of the surface. Anything below excellent, you may be able to see the polish defect under 10 times magnification. Symmetry, as its name implies, is how symmetrical the diamond is cut. To analyze a diamond's optical symmetry, the hearts and arrow scope is used. Lastly is the fluorescence, which has a scale from none, slight, faint, medium, strong, and so on. Fluorescence is when boron particles are trapped inside the diamond. If you see a diamond with fluorescence indoors, there will be no visual difference. However, when you view it outdoors, specifically under sunlight or UV light, it may cause the diamond to have a chalky, milky, or oily appearance. Also, fluorescence can come in various colors such as yellow, green, or red, with the most common color being blue. So what this means is under sunlight, the diamond may appear chalky or milky and have a slight off color. In the bottom middle of the report is what we call a clarity plot diagram. The left shows the top half of the diamond and the right is the bottom half. If you look carefully, there are some red markings on it, which shows you the location of the inclusion. It is important to note that it only reveals to you the location of the inclusions, but not its severity, meaning how deep or obvious it is. For example, sometimes a VVS2 diamond can have more red markings than a VS1 diamond, but that doesn't mean it's worse. The small inclusion marks on the VS1 can be more deep or severe than the multiple inclusion markings on the VVS2. Hence, you should only use the clarity plot diagram to see where the inclusion is, but not use it to judge its severity. At the bottom part, it reveals the clarity characteristics of the diamond, meaning the type of inclusions the diamond has. It's also important to note that the more types of inclusion the diamond has, it does not mean the worse it is. For example, we have two VS1 diamonds. One has a crystal inclusion, the other has a crystal, cloud, needle, and feather inclusion. But they both have the same clarity grade. What this means is that the first diamond can have multiple crystal inclusions or a big crystal inclusion, while the other have a very minor inclusion of each type. This is why they still can receive the same clarity grade. But whenever you're in doubt, you may ask your jeweler to show you the inclusions under a magnification loupe. Okay, next we'll move to the last part, which is the proportions. Different diamonds will have different proportions and parameters. I'm sorry, but this part is going to be quite technical, so try to bear with me. But trust me, this is a very important aspect in a diamond that you have to know. First, we have the table, which is 56%. This is the biggest facet of the diamond, and the 100% is the diameter of the diamond. Basically, the larger the table, the brighter and bigger the diamond will look, while the smaller table will have higher fire and scintillation. So what you want is something in between, where there's a balance between both. Then we have the depth, which is 61.4% of the diameter. A diamond that is cut too deep will have carat wastage, making it appear smaller, while a depth that is too short results in a shallower cut diamond, and it can suffer from light leakages. So what you want is a balance. As a rule of thumb, you don't want a diamond's depth to be over 62%. Next, we have the crown angle and pavilion angle, which affects the brilliance of the diamond. For example, a higher crown angle can result in higher fire, like what you see here, which results in over-contrasting. However, if the pavilion angle is too high, it will cause severe light leakages. To compensate for the higher crown angle, the pavilion angle has to be lower. Likewise, a lower crown angle can result in better brightness at the expense of lower fire. However, the pavilion angle has to be steeper in order to compensate for this. In other words, the pavilion angle and crown angle has an inverse relationship where one needs to be higher when the other is lower, vice versa. But of course, both still have to be kept within the ideal range. The goal is to find that sweet spot and balance. This is where our super ideal cut diamonds comes in, where we ensure that all of our diamonds have that perfect balance to achieve the optimal brightness, contrast and fire. Okay, to sum it up, a crown angle that is too high will result in over contrasting, like what you see over here. Although larger contrast can give higher fire, too much contrast will reduce the brightness of the diamond, making it less brilliant. To balance this, the pavilion angle has to be lower. Now if the crown angle is too low, it will increase the brightness of the diamond, but at the expense of lower fire, like what you see over here. It does not have the 8 distinct arrows anymore, resulting in less fire and also lower brilliance. This is where the pavilion angle has to be higher to compensate for this. When both the crown angle and pavilion angle is balanced, the diamond would achieve the optimal balance of brightness, fire and scintillation, like what you see over here. Each of our super ideal cut diamonds are handpicked to ensure that their crown and pavilion angles are balanced to have the maximum brilliance. Now all these proportions might sound mind-boggling and you might be wondering, so what's the best proportion? Well, the answer is, there will never be the best proportion as everything is all about the balance. But to save you some headache, there are ideal proportions for a diamond. The easiest way to check is by using the HCA tool, where you should try to aim for a score of 1.4 or below. The HCA tool is a free online tool where you can key in a diamond's proportion to generate a score. However, I must emphasize that you should only use this tool as an elimination tool to weed out poor performing diamonds, as it does have several limitations. Next up is the lower girdles and star facets. Longer lower girdles creates thinner arrows, which will have more scintillation from more hot spots due to the larger contrast in the stars, and it will have higher scintillation at the arrow shafts as well. When the star facets are bigger in such a diamond, more fire can be seen through the stars. This results in higher scintillation in the diamond. Now when you have a shorter lower girdle, it produces thicker arrows, resulting in larger flashes of fire. But if you notice, the hot spots produced in the star and arrow shafts are less. Typically, the star length will not affect so much in such a diamond because the star is only acting as a window. As such, you can see the hot spots in the stars. The thicker arrows results in larger flashes of fire, but less scintillation due to the lesser hot spots. And it will produce such a type of contrast characteristics. Okay, so there you have it guys. This is everything you need to know about the GIA certificate. With this information, you're halfway there in finding your perfect diamond. Now the next half is about what the GIA certificate does not tell you. There are many things that is not shown on the certificate, such as the light performance and optical symmetry. These are very important factors that is what make a diamond brilliant. In our next video, we'll be sharing with you how to find a high light performing diamond. So stay tuned and thank you for watching this video.